All right, so let's see what we remember about normal distributions. We haven't talked about them much, but we have talked about SOCs. So I want to take a look at a bell curve and review the idea of SOCs on this bell curve. So normal distributions are bell-shaped, they're symmetric, they technically have an infinite base. And now that we're going to start talking about the normal distribution, specifically in chapter 6, it's going to be with us for the rest of the semester. It's huge. All right, we love these bell curves. Now, typically on a bell curve, your variable will be along the x-axis and probability will be along the y-axis. There will be a special case called the standard normal distribution where we will have z-scores on the x-axis, but let's put a pin in that until we get to the next page. So the normal distribution has two parameters of interest: the mean, the number that comes right below the peak here, and the standard deviation, which tells us how far out to go on our tick marks. And you'll see in a few, we usually go 3 up and 3 down, all right? When a continuous random variable can be approximated with the normal density curve, we write this symbol. So here we go, you're seeing the squiggles again. So my variable is distributed normally. The mean is mu, the standard deviation is whatever it is, it's sigma. So mu always comes below the peak. All right, and then this sigma will help us put numbers along the x-axis. I usually go 3 up and 3 back, or if I'm feeling lazy, I'll go 2 up and 2 back, but we'll change it up as we start going through these problems. All right, so we're gonna take a look at example 4, and again, I just want us to concentrate on the SOCs on this. I'm not asking us to do anything unique to the normal distribution. So let me move this up so we have it in view. All right. So we have the following graph summarizes data collected on annual rainfall in inches in 2 cities for the past 150 years. Which of the following conclusions can be made from the graph? So we've got averages and ranges in our answers. And again, that comes back to SOCs. This has nothing to do with the calculations we're going to make in chapter 6. I want us to just review this idea of SOCs here. So here you see city A's got the lighter distribution, city B. This is the one that's actually the normal distribution. You can see it's perfectly symmetric, it's bell-shaped, all that fun stuff. But let's compare SOCs. Let's do city A's SOCs down here. And let's do city B's SOCs over here. All right, and before I get going on anybody's SOCs, I need to figure out what the variable is. And you can see it's just labeled right here, amount of rainfall. So rainfall, and they gave me the units, it's in inches, right? Annual rainfall in inches is my variable. Okay, it's continuous numerical, right? We would measure the amount of rain that we collected annually. All right, so let's try and figure this out. So for city A, you can see that it's not perfectly symmetric. I mean, you could almost say roughly symmetric, but it's a little skewed right for its shape. Now, city B is definitely roughly symmetric, but now that we're picking up the bell curve, we're going to start throwing in this symbol. It's approximately normal. So that's going to be a very common symbol. So I want you to hear, if you told me roughly symmetric, great. But I want us to try and push past that in chapter 6. If it's got the bell curve, we're going to start to throw out the approximately normal. All right, in terms of outliers, I don't have the raw data, so I can't crunch the IQR and build a safety zone. So I'm just going to leave this as a question mark for right now. All right, I don't know enough to comment one way or the other. All right, for the center, let's look at city A. I feel like the center is somewhere around here. That seems to be the number under the peak, right? We can see the peak. So maybe about 17, 18 inches of annual rainfall. I'm just gonna say 17 since I'm approximating. So I think 17 inches seems like a good approximation for the center for city A. For city B, it's looking like that peak is coming right around 30 inches. Okay. Now for our measures of spread, I could quote the range, I could quote the spread. I couldn't really quote the IQR because again, I don't have the raw data don't know the standard deviation and the variance because I don't have the raw data to crunch that number. So I'm just going to quote spread. If I'm looking for A, it looks like it goes from 5 to maybe 40. Maybe it goes a little past 40, but how about we'll say 5 to 40 inches. All right, this is spread. Now, I personally like range better, so I just want to think of the range. It's about 35 inches. All right, I'll put the approximate symbols. I'm not 100% sure because if I look at it really closely, it looks like this might extend a little bit further than 40. All right, for city B, it looks like it's pretty much going from 20 to 40. Again, it might extend a little bit more than that, but as long as I'm just approximating, 20 to 40 seems fine. So the range here is around 20 inches. Okay, so keeping all of that in mind, we've got to figure out which option, A through E, is correct. So this is a multiple choice question. Which of the following conclusions can be made from this graph? So let me push this up so we can start to see all of our answers. Let me get E up there. Okay, so let's see if we can figure this out. So if we look at the answer or the option for answer A, it says the cities have different mean rainfalls. Well, that's true. They do have different averages. All right, but the range of their annual rainfalls is approximately the same. Well, that sentence is not true. All right, they do have different averages, I'll give you that, but their ranges are not the same. So A is not the correct answer here. All right, on average, City B gets more rain than City A. Well, let's look. City B got 30 inches, City A got 17. So yes, that's a true sentence. All right, but has a smaller range of annual rainfall. So City B gets more rain, but has a smaller range. So let's take a look. City B, it does get more rain, right? And it does have a smaller range. So this is also correct. This is going to be our answer. All right. Now, I know we didn't go through all of these because when we were going through, B wound up being the correct answer. But let's also just analyze why some of these are incorrect. This is true. City B does get more rain than A, but it does not have a larger range, right? This is off in that City A does not get more rain, right? So D and E get ruled out for this part, and C gets ruled out for that part. All right. So with that, we're going to continue on learning a lot more about normal curves.